Welcome to Across the Globe. Today we will learn about Principal Component Analysis, PCA. Principal Component Analysis, PCA, is a technique utilized for dimensionality reduction in fields such as machine learning and statistics. By transforming data into a new coordinate system, known as principal components, PCA helps in identifying patterns within the data. These principal components are orthogonal vectors designed to encapsulate the highest variance present in the dataset. An example of PCA application can be seen in image processing, where it is employed to reduce the dimensions of image data while preserving essential features, aiding in image compression and analysis. Principal component analysis is a technique used in data analysis to reduce the dimensionality of a dataset by capturing the most important information. It does so by finding the eigenvectors and eigenvalues of the data's covariance matrix. Eigenvectors signify the directions of major variability, while eigenvalues quantify the amount of variance along each eigenvector. By projecting the data onto these principal components, PCA retains key information by prioritizing components with the greatest variance. For instance, in image processing, PCA can be employed to compress images by preserving critical details while discarding less significant information. Principal component analysis, PCA, is a technique used for dimensionality reduction and feature extraction in data analysis. It works by transforming data into a new coordinate system composed of principal components that capture the most variance in the data. In the provided example, a dataset containing information about houses such as square footage, number of bedrooms, and price is created. By applying PCA with two components, the three original variables are projected onto a new two-dimensional space. Essentially, PCA helps in simplifying complex datasets by extracting the most significant aspects and visualizing relationships between variables. For instance, in real estate, PCA can be applied to analyze housing market trends by reducing various property features into a few key components for better understanding and decision-making. Principal component analysis, PCA, is a technique used to simplify and reduce the dimensionality of complex datasets. By transforming the original variables into a new set of uncorrelated variables called principal components, PCA can capture the most important information while discarding redundant information. In the context of machine learning, PCA can enhance model performance by eliminating irrelevant features, which reduces overfitting and computational complexity. For example, in a dataset with multiple correlated features related to a target variable, PCA can help in identifying the key components to focus on, enhancing model accuracy and efficiency. Moreover, PCA facilitates data visualization by projecting high-dimensional data onto a lower-dimensional space, making it easier to interpret and analyze complex datasets. For instance, in the analysis of gene expression data, PCA can help visualize gene relationships and clustering patterns by reducing the number of dimensions without losing critical information. In sum, PCA is a powerful tool for simplifying complex datasets, improving machine learning model performance, and aiding data visualization, making it an invaluable technique in various real-world applications. Imagine you have a large pot of soup with many different ingredients mixed together. PCA is like a recipe that helps you identify the most important ingredients in the soup that contribute the most to its overall flavor. By applying PCA, you can reduce the complexity of the soup to just a few key ingredients, making it easier to understand and analyze. In a program, PCA can be implemented by breaking down the soup into its individual ingredients, determining their individual contributions to the flavor, and then combining them back together to create a simplified version of the soup that still retains its original essence. Hey, Code Conquerors, ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. The code showcases the implementation of Principal Component Analysis, PCA, on a hypothetical dataset representing soup ingredients. The NumPy library is utilized to create a matrix of ingredients, where each row signifies a different ingredient in the soup, and each column represents a specific component of the soup, such as carrots, onions, potatoes, etc. With the help of scikit-learn's PCA module, the code applies PCA with n components equals 2 to the ingredients matrix, aiming to unveil the essential components that influence the soup's overall characteristics the most. The percentage of variance explained by each principal component is printed out using PCA explained variance ratio. Following this, the script reveals the principal components, or key ingredients, identified by PCA. It iterates through the components and presents the contribution of each original ingredient to the principal components, offering insights into which ingredients play crucial roles in defining the soup's flavor profile. The last segment of the code involves reconstructing a simplified version of the soup using the calculated principal components. By employing PCA.inverse transform, the script generates an approximation of the original soup based on the key ingredients identified by PCA. Overall, this narrative provides a clear understanding of how PCA can be applied to extract essential components from a dataset, in this case soup ingredients, and how these components can be used to simplify and potentially enhance the analysis or interpretation of the original data. One real-world application of principal component analysis, PCA, is in finance for portfolio management. In finance, PCA can be used to reduce the dimensionality of the stock market data by identifying the most important factors that drive the behavior of stocks. By applying PCA to historical stock price data, analysts can extract the principal components, key factors that explain the variance in stock returns, helping in constructing diversified portfolios efficiently. Another industrial application of PCA is in image compression and facial recognition systems. In image processing, PCA can be employed to reduce the dimensionality of image datasets while retaining essential information. By extracting the principal components representing the most significant features of the images, PCA enables efficient storage and transmission of images with minimal loss of visual quality. This technique is widely used in facial recognition systems to identify key facial features that distinguish one individual from another. By leveraging PCA, industries across the globe can gain valuable insights, optimize processes, and enhance decision-making based on key components extracted from complex datasets. Keep learning, stay curious, and I'll catch you in the next video.